Perfect. I think we'll make a start then. So good evening, everyone, and welcome to this webinar as part of the Sustainable Sheep System series. My name is Daniel Stout, and tonight we'll be looking at blowfly strike in sheep. So tonight's webinar, looking at blowfly strike, will run for about an hour. So we'll have a presentation from Professor Richard Wall from Bristol University, and then we'll have plenty of time for questions. So please do put as many questions as you can into the chat, and we'll have a good discussion at the end. Just a quick bio on Richard. I think it's always interesting to know where people have been and what they've done. So Richard graduated in zoology from the University of Durham before completing a PhD in insect population ecology at the University of Liverpool. He then specialised in veterinary entomology at the University of Bristol, where he's worked ever since, working on the ecology and sustainable control of ectoparasites, including blowfly strike, our topic for tonight, and vectors and their impact on animal health. His current research focuses particularly on ticks and mange mites causing scab, and considers the impact of temperature and humidity, and hence climate and climate change, on their patterns of activity and abundance, as well as looking at non-conventional approaches to ectoparasite control, including essential oils, and the environmental impacts of veterinary parasitides. He has co-authored over 250 research papers and 3 textbooks, with one coming out soon, and has been awarded both the WAAVP Peter Nason Prize and the Award for Research Excellence in Veterinary Parasitology. So I don't think we could have a better person with us tonight to discuss blowfly strike. Well, this webinar series so far, so it's a 5-part series over the winter. We've already had a night on yoni disease with Dr. Craig Watkins from Morden, and Laura Green joined us to look at lameness and foot rot on the 21st of November. And those two, along with tonight's webinar, are all recorded and will go up on the FAS YouTube site in due course. And everyone tonight will receive an email from me a bit later on with the links to rewatch those. So I'll keep you up to date. We're then going to be back again after Christmas in January, looking at ewe-lamb selection. And then to wrap up the series, tying both that genetics and the health trait side of things, we've got Dr. Mark Ferguson from NextGen Agri in New Zealand to discuss genetic resistance to both foot rot and blowfly strike, and their work, mostly merinos, where they found strong genetic resistance traits to both of these health traits and strong indicators for selection and the development of EBV. So really excited to get Dr. Mark Ferguson over. If you've got any questions, we would ask, could you please put them in the bottom bar, but put them in the Q&A box. If you've got any more private questions, say your tech's not quite working, I would ask that you put them in the chat. But any questions for Richard, please put in the Q&A. And bear in mind that we are recording tonight. And finally, as always, I'll just ask you to please fill in the feedback form when you get it after the webinar. It really does help us improve. Your feedback helps us know how we can improve what we're doing, identify new ideas and things that you want to look into. And it also helps us feedback to Scottish Government, because bear in mind, it's Scottish Government that funds FAS and funds all this. And so we have to demonstrate value in it. So we really would ask that you do that. I'm now going to pass you over to Richard, and then after that, we'll go to questions. So I'm going to stop sharing, Richard, and pass over to you.
Good evening, everyone. It's a great pleasure to be with you this evening to talk about my favourite subject, blowfly strike. The first thing I need to say is, as was said in the introduction, I've worked down in Bristol for about the last 40 years. So all of the data I'm going to show you and all of my experience has really been in the southwest of England. So I'm conscious that I'm talking to a Scottish audience, so we need a bit of interpretation when we move from a sort of lowland, southwest of England setting up to. Right, so the first thing is that in most of northwest Europe, most of the UK, the main species that's responsible for blowfly strike is a green bottle called Lucilia sericata. It's certainly down in the southwest here, it's about 99% of all strikes only contain this one species. There are several other species of Lucilia that we get in the UK, and it's quite interesting as you go up through northern England into Scotland, you begin to get this one other species, Lucilia caesar, in strikes, but even then, Lucilia sericata is the main green bottle that you get in blowfly strike. So predominantly we're talking about this species. What's quite interesting for the entomologist is there are lots of other shiny green flies as shown on the screen here, none of which cause blowfly strike. It's actually quite difficult with the taxonomy of these things. If you're looking for shiny green flies, you can't simply equate the presence of shiny green flies being seen flying around on the farm with the risk of strike, because there are so many flies that look very, very similar. As none of these flies actually at all. The life cycle of sheep blowflies is quite simple. So the adults lay batches of eggs, and every time they deposit the batch of eggs, it's about 200 eggs at a time. And those eggs are sort of creamy and white in color, and are laid in the wool close to the skin. I've got a picture here. You can see the batch of eggs laid here, or clumped together in that wool. And the larvae hatch from the eggs, and they crawl down the fibers of the wool onto the skin. The eggs hatch in about 12 hours, but they do need a relatively high humidity to be able to hatch. They need a humidity of about 65% or higher to be able to hatch. So the larvae, the first stage larvae, crawl down onto the skin, and they begin to feed at the skin surface. And they secrete proteolytic enzymes in their saliva that begin to sort of essentially digest the surface of the skin. And in the later larval stages, they've got quite large mouth hooks that they use to scrape away and abrade the surface of the skin. So they fairly quickly begin to produce a lesion on the skin. And the feeding stage, there are 3 larval feeding stages, and the whole process from egg to the end of larval feeding takes about 3 days. They can get through that component of their development really quickly. And that's an important point when we think about the management of blowfly strike. Once they've got to their 3rd maggot stage, they stop feeding, they empty the gut, and they crawl away from the lesion that they've created on the skin. They enter what we call the wandering stage, where they drop off the sheep and then migrate over the surface of the soil, and then they burrow into that upper layers of the soil and they pupate. In that process of pupation, they completely transform their bodies to create the adult form within the pupa. And then several weeks later, the adult fly then emerges from the pupa. And whereas the egg and the feeding larval stage have a very discrete time period because they're on the sort of warm, protected surface of the skin, the wandering larva and the pupa can be very variable in duration depending on the temperature and humidity of the outside environment. So they're much more variable in how long they take. Now, when the larvae start feeding on the skin, they produce this lesion. And a single batch of larvae, around 200 or so, will produce a lesion about the size of my hand. But it's not a huge lesion. And the size of that lesion is directly proportional to the number of larvae. And generally, the feeding will result in tissue damage, inflamed areas of skin, but generally small numbers of larvae, like a single egg batch, will do relatively little other than superficial damage, and the wounds usually heal fairly cleanly. And it's quite an interesting thing that the saliva of blowfly maggots actually contain a natural antibiotic. So the wounds generally remain fairly clean and heal fairly well. And the fact that they do have this natural antibiotic is one of the reasons why they're quite often used these days in maggot therapy or larva therapy. So when in humans we get wounds that aren't responding to antibiotics, resistance within the bacteria that are infecting the wound, then you can use Lucilia sericata maggots to actually clean that wound and abrade the wound surface, and that wound will heal much better for having had the maggots on it. And in fact, I do know some farmers that have used maggot therapy to try and heal wounds, particularly on cattle. So if you have a non-responding lesion on a cow, I know farmers have put flakes of maggots onto that lesion and they'll clean it up. And it usually heal much better as a result. So it's really interesting that the maggots have got this natural antibiotic in their saliva. So the problem really isn't single oviposition events, single batches of larvae, single batches of eggs. The problem is that once you get an initial infestation, it smells, it begins to produce an odor which is extremely attractive to more flies. And as I'm sure all of you know, you get that smell of infestation, and the fleece is wet to the touch. And you can actually, with high infestations, you can hear it crackling, almost like Rice Krispies, as all the maggots sort of crawl over each other. And this picture I've got here shows what a late stage infestation This animal's probably been infested for at least 3 weeks. You can see on the right hand here that there's an area of scar tissue, which was probably the area where the animal was struck first. And that's largely healed, and the maggots have moved away underneath the wool. And that dark discolored area is really wet to the touch. The maggots on this particular animal were all the way underneath it. And you can see there were flies landed on it, and just down to the right at the bottom of this area of scar tissue, you can see more batches of eggs. And this animal died shortly after the photo was taken. So it's the multiple infestations, it's the attraction to the wound of other blowflies, which actually causes a fairly rapid buildup of infestation. And the animals will eventually suffer severe toxemia and fluid loss. The toxemia will affect the kidneys and the heart, and the animal will die. So it's multiple infestation, which is the problem. And once they start being multiply struck, the animals become lethargic, depressed, various behavioral things can be seen. They might not gather. The animals might separate themselves away from the rest of the flock. And the problem is that then they're easily missed. So if they tuck themselves away into hedges and ditches to move themselves away from the rest of the flock, then they can very easily be missed in this condition. In terms of the prevalence of strike, we did the survey, the last survey, big survey that we did was about 20 years ago, just under. We did it throughout England, Scotland, and Wales. About 1,067 farmers were surveyed in this study. And we asked farmers about the prevalence of strike on their farms. And the data shows that you get quite a large degree of variation across England, Scotland, and Wales. This is Scotland down here. This is the percentage of farms that experienced at least one case of blowfly strike in the season in question. And you can see it's around 60% for Scotland, whereas down in the southwest, it's much higher. It's around 80 to 90%. So we get a very strong geographic variation across the country in terms of the number of farms that get strike. Wales is also relatively high. In terms of the number of animals that are infested, this figure shows the percentage that were infested in the year that we did the survey. And the blue bars are the numbers of ewes, the red bars are the number of lambs, and the yellowish bars are the number of rams that were struck. And the data for the number of rams is a bit less, you can be a bit less confident in it because there were much smaller numbers. But generally, we find that we get something between about 1% and 2% of ewes will be struck each year. It's higher in the southwest and the southeast than it is in Scotland and the north of England. Okay, so we're talking about the percentage of ewes, lambs, and rams that are struck. And Scotland, in this particular survey, we had around 1% to 2%, whereas in the southeast and southwest, it's much higher. It's around 3% to 4% of lambs struck each year. Okay, so these are the sorts of numbers that we typically expect to see with the use of insecticides. So even with the use of insecticide, we would expect to get 2% to 4% of lambs and 1% to 2% of ewes struck each year. It's much harder to get data on what we would expect to see without the use of insecticides, but we do have some. And this is a study where we had 3 farms that didn't use any preventative treatment over the course of the year, and we monitored the cumulative percentage of ewe strikes and lamb strikes over the course of that year. And you can see from this data that the numbers of cases in ewes, percentage of ewes struck in this year increased fairly rapidly. Day 1 is the 1st of January. So this is going through May into June. The numbers of strikes in ewes increased very rapidly, got up to about 10% to 12%. Then all the animals on the 3 farms were sheared, and shearing prevented any further strikes. If we look at the lamb strikes, again, the same time base, the numbers of lamb strikes begin to increase over the course of the year. We get to about the beginning of July, numbers of percentage of lamb strikes increased rapidly. And we ended up with about 14% to 16% of the lambs were struck in this study. One of the farms didn't have such a high rate of strike, but in 2 of them, we had quite a high rate. So generally, without appropriate insecticide use, we would expect strikes to be on average around 10 to 15% of animals, particularly in lambs. So about 10 times higher than we would expect to see with appropriate protective control applied to sheep. So that control clearly is keeping the prevalence of strikes relatively low. In terms of the susceptibility of animals to strike, essentially there are two things which are going on at the same time. We need to think about the factors which affect the blowfly life cycle and the factors which affect the susceptibility of ewes and lambs. Now, the blowfly life cycle is driven predominantly by temperature and rainfall. Temperature affects when flies lay and whether eggs are going to hatch on infested animals that are struck. In terms of the susceptibility of ewes and lambs, the factors that are of critical importance are soiling, the amount of feces accumulating around the back end of the animal, and the rainfall, because the rainfall affects the humidity on the sheep. In many cases, with say a freshly shorn ewe, it'll be too dry on the surface of the skin for the eggs to hatch and the larvae to survive, unless the animal is wet through rainfall. The rainfall affects humidity, and that affects egg hatch. Pasture worms are the factor which predominantly drives the fecal soiling in sheep. And so pasture worms becomes particularly important when we think about what's affecting soiling and what's affecting the risk of strike. And both soiling and humidity can be affected by fleece length. The longer fleeces, you're more likely to get feces adhering around the back end of the sheep, and you're more likely to get a sheep that gets wet and stays wet after rain. So the combination of pasture worms, rainfall, and fleece length are what's driving the pattern of susceptibility of ewes and lambs. If we take our knowledge of the life cycle and the risk factors, we can actually think about these risk factors in a little more detail. And the first one is temperature. So temperature is one of the major risk factors. And essentially, we need temperatures above about 9 to 10 degrees centigrade to get strike. Below about 9 degrees centigrade, flies generally don't oviposit. Unless they're in a very protected microclimate, then that's generally considered to be the cut-off threshold temperature for strike. And as temperatures go above that, then the risk of oviposition becomes higher. Strike risk is positively related to rainfall. As I said, because animals get wet and because the eggs and the first stage larvae in particular need high humidity, the risk of strike will be affected by increases in rainfall. The risk of strike is related to the numbers of flies that are around. The more flies, the higher the challenge for sheep and the greater the risk of strike. And the fly numbers will increase over the course of the summer. So the first flies emerge in early spring, and the population of flies generally increases gradually over the course of the year through to about September and October. So as the fly population increases, the risk of strike will also go up. The risk of strike can also be positively related to the availability of fallen stock, carcasses, because these flies will also breed in carrion, dead animals left lying around, if they are. So prompt removal and good disposal of carcasses can also be extremely important in helping to reduce the blowfly population. And if animals are left lying around, if carcasses are left lying around, you can get hundreds of thousands of flies emerging from particularly a large animal carcass, and then adding to the population of blowflies and increasing the strike risk. So good management of fallen stock is important. Again, as I said, fecal soiling is one of the critical factors. So reducing fecal soiling either through good worm control, or ideally through both good worm control and through removal of that feces, dagging and crutching can be important. Particularly for lowland animals, can also help to reduce the risk of strike. I'll say a bit more about that in a minute. Yeah, sure. But tail docking, sorry, is the one I was going to say a little bit more about. Tail docking can also help to reduce the risk of strike. I thought it might be worth just showing you some data on tail docking, because there's been quite a lot of debate recently about whether tail docking is something that needs to be done. Again, I should emphasize that I'm talking primarily about lowland animals rather than upland animals. I'm not going to say very much about foot rot because I know you had a good talk last week from Laura Green on foot rot. Foot rot can also predispose animals to foot strikes, but I'm really focusing primarily on body and breech strikes in this. So I want to say a little bit more about tail docking. This was a study that we conducted quite a long time ago now. It's one of the first things we did on blowfly strike. And it's a study where we took 7 farms in southwest England and we compared 3,000 animals, half of which were docked and half of which were undocked. And we followed the incidence of strike on those docked and undocked animals over the course of the year. We also recorded growth, mortality, and strike rates on all the farms. And what you can see in the graph here is the incidence of strike, number of cases of strike per 1,000 lambs, and this is time. This is the week of the year on this axis. And the dark bars are the numbers of strikes in the undocked lamb, and the open bars are the number of strikes in the docked lambs. And we had a very, very clear result in the study. But it was so clear that we had to abandon the study 3/4 of the way through because the level of strike in the undocked lambs was so high. And you can see from the graph that the strike incidence was about 5 times higher in undocked than docked lambs. So certainly for lowland animals, we had a very clear result that docking contributed significantly to reducing the risk of strike. And we not only did it help to protect them against blowfly strike, but we had relatively little evidence of any detrimental effects of docking on lamb mortality or growth rates. So certainly from this study, we get quite a clear positive effect of tail docking on blowfly strike. So we can reduce and manage the risk of strike through a number of measures. The first would be good parasitic worm control. So if you can reduce the burden of parasites on pastures, you reduce diarrhea, you reduce the level of fecal soiling, and that would have a significant effect on reducing the risk of strike, particularly in lambs. As I've said, tail docking is extremely important in lowland flocks. Dagging and crutching can be important to help to reduce fecal soiling around the breech area of lambs. Foot rot control can be important for managing foot strikes. Shearing has a big impact. But one of the interesting things about shearing is it will very rapidly reduce the risk for ewes, but can actually, in some studies, we've seen it increase the risk for lambs because you have a population of flies that are all ready to oviposit. And if you reduce the fleece length on ewes, then those flies are looking for the next best oviposition site. But you can actually get higher rates of strike on lambs immediately after the ewes are sheared because those flies will want to lay their eggs somewhere and they then fly off and choose the lambs. So shearing certainly protects ewes, but can have detrimental effects on lambs in the same area. Of course, frequent flock inspection, especially at high risk times, is extremely important to try and catch those animals that have been struck and are beginning to show behavioural signs such as moving away and hiding away from the rest of the flock. As I said, good foot and stock management is important, but also appropriate insecticide use. So I just thought it would be worth, in terms of the appropriate insecticide use, just having a little look at the seasonal pattern of blowfly strike and thinking about how that relates to the use of different types of insecticides. So here we've got on the vertical axis the number or susceptibility of animals, and we've got time along the bottom axis. So we can think, first of all, of the fly population. Those flies usually emerge sometime in early spring. And again, that will vary where you are in the country. They emerge considerably earlier in the year and in the southwest than they will do up in Scotland. But we usually get flies emerging sometime in March, early April, whereas further north it'll be much later, April going into May. The fly population goes through 4 or 5 different generations every year, so increasing in abundance all the way through to August, September. What actually happens in September is that the last generation of maggots don't go into pupation. They drop off the sheep and they go into diapause. They crawl a bit deeper into the soil and they overwinter in the state of diapause. In that diapausing state, they're very, very resistant to cold temperatures. They're overwintering at this very moment as maggots in the soil. And when the spring temperatures warm up, those maggots will pupate and trigger off the first generation of adults some weeks later. So we get the fly population building up from the beginning of the season through to late autumn, late summer. Now, you think about the susceptibility of ewes, as I've said, the susceptibility increases over the course of the spring. The longer fleeces, the accumulation of feces around the back end, combination of the interaction with weather and all these factors, and the increase in the fly population increases the susceptibility of ewes over the course of the spring period. And then we get shearing and the susceptibility falls dramatically. So then the ewes become much less susceptible for a period until the fleece begins to regrow. And as that fleece regrows and as the weather begins to deteriorate towards the end of the summer, then the ewes become increasingly susceptible once again. That's the general pattern of ewe susceptibility. For lambs, it's different. Obviously, it's going to depend on when lambs are born, but just for the sake of this particular example, we'll say we've got a flock where the lambs are born sometime in April, and they begin to become susceptible to strike once the wool begins to grow. The wool begins to grow, then the lambs will hit pasture nematodes going through the middle of the summer. And that can trigger diarrhea, and they become much more susceptible to strike. At the point where the ewes become less susceptible to shearing, the lambs are increasing susceptibility extremely rapidly at that time. Then obviously the lambs gradually get sold off the farm and disappear in the system. So that's the general pattern of changing susceptibility of ewes and lambs on a farm. Then we can, on top of that, think about control. In terms of ewes, we've got this initial period. Now, this is going to vary quite dramatically in terms of where you are in the country. And it depends on the weather in any particular year. This year, we had a very late spring. So this period, the early season susceptibility of ewes was quite short down here in the southwest. But when we get a warm early spring and the ewes begin to become susceptible quite quickly, when the fly population begins to build up quite quickly, then we get a period before shearing when ewes are susceptible. Now, many farmers will try and get away without applying an insecticide at that time. But if we have an early spring and the fly population emerges quickly, and then the animals are susceptible, we can get quite significant levels of strike in the ewe population at that early time of year. In many cases, people will try and just get away with not applying anything to the ewes. They then get sheared, they're less susceptible. And so people don't normally need to worry about them immediately after shearing. But this early season period of susceptibility can be quite significant for ewes, but it does depend on the local climatic conditions and how early the fly population emerges. I guess it's more of a problem for us down in the southwest than it would be certainly up in the north of Scotland. Once the ewes sheared, of course, the susceptibility is very low for a period, and that susceptibility increases. So gradually, people need to think more about treatment, and particularly, again, late season treatment needs to be given careful consideration. And again, this depends on the local weather conditions. If we get a quick onset of winter and early frost, generally what kills the last adult flies off will be the onset of frosty weather. If we get early onset of cold weather, those flies disappear, then we don't need to worry too much about those late strikes. But if we have a warm autumn, then that period of relatively high ewe susceptibility can be quite a problem. Certainly down here, we had strikes all the way through to the middle of November this year. So that is a period where, traditionally people might say, well, we don't really need to protect ewes. They've been protected over the course of the summer as a result of shearing. Do we need to apply something? but certainly when we have a late, warm autumn, then we do need to protect you at that time. So the whole thought process about what we need to apply and when we need to apply it needs to be linked to what the weather conditions are in any particular. For lambs, it's relatively straightforward. Of course, as they increase susceptibility over the course of the year, then they need to be protected at that period of peak susceptibility. In terms of what products can be used, there's a wide range of different compounds. Essentially, they're the organophosphates, the insect growth regulators, and the pyrethroids are the three classes of product which are available. However, generally, the advice these days is not to use organophosphates for blowfly strike, because really we want to try and preserve those compounds for use against sheep scab. So for the other products, it's really a question of thinking fairly carefully about the residual activity of each of those products and the withdrawal period, and then linking in the time of application with those two factors, how long the animals need to be protected for, and what the withdrawal period is and when those things are applied. So, for example, if you were treating ewes at the beginning of the season and you didn't want to have product on those animals when they were sheared, then you would pick something with a shorter period of residual activity, so that the product wasn't available at the point of shearing. So you need to link in exactly which product is being used with when it's being applied and for which category of sheep. Final thing I'm going to say is just one of the things that we're particularly concerned about at the moment is the impact of climate change, because blowfly strike is so variable and it's so dependent on the local climatic conditions. If we do get changes in climate, we're expecting to see fairly significant effects on the blowfly season. We're expecting to see longer blowfly seasons with earlier emergence of the flies, and then strike risk remaining all the way through the season, as we saw this year down for us in the southwest, all the way through into November. And it wouldn't take too much, certainly for most lowland flocks, it wouldn't take huge increase in temperature to get fly strike going through the winter. So it needs about a 1 or 2 degrees centigrade increase to get fly strike going all the way through the winter. So it's something which we're concerned about and we need to think about going forward into the future. But it's perfectly possible, depending on the level of climate change that we do see, that in some parts of the country, certainly in parts of central southern England, it might actually get too hot and too dry to get significant levels of strike in those areas. So climate change is something that we're giving a lot of thought to at the moment, changing the nature of the blowfly strike season, because it is so dependent on the local climatic conditions. Okay, I think I'm going to leave it there because I've probably used up most of my time.
Perfect. Thank you very much, Richard. I mean, if you've only got 1 or 2 more slides, you're welcome to do them.
I've just got one more slide, but I'm going to leave it to see if there's a question about it.
Okay. Perfect. Let's get the questions up. Was the strike risk in undocked lambs the effect of soiling, or was it independent of this? This is crucial in light of the reports of the English AWC that suggest that docking should be stopped as a routine from 2028 unless a vet certificate is obtained to suggest it is essential. But it really is coming to the fore, isn't it?
We think it was an effect of soiling. So the animals with the tails were more heavily fecally soiled. So you could leave the tails on and just spend a lot more time with better worm control or decking and crutching to actually get rid of the pieces around the back end. So yeah, that's another way of doing it.
Yeah, and we're going to have Dr. Mark Ferguson on in a couple of months' time talking about the genetic side as well, because we know there's quite a strong heritability to things like body breach or breech bareness, breech wrinkle, dags as well. We know they're good heritability. We know that they're correlated as well to the fly strike resistant side of things. So I think there's always a genetic element we can pull in as well.
Yeah.
I was wondering, has there been any work, because there is some good work kind of South Africa, mostly I guess in merinos, where there's such a big problem. They've had a history of having to mules, and they've had to move away from that from other welfare grounds. So there's a lot of research coming from New Zealand, Australia, South Africa. Has there been much in the genetic side over here?
Very, very little as far as I'm aware.
Yeah.
I mean, we know that the more open-walled breeds are less susceptible. Wiltshire horn, shell-shedding sheep,
Yeah.
obviously less susceptible. Um, but there's very little of specific genetic work being done on it.
No, that'll be right. I think we've got a very similar question here. Will breeding for bearer tails or breeding for sheep with better worm resistance be beneficial?
Breeding for better worm resistance, yeah, definitely. Because stopping that fecal soiling, I mean, anything which actually improves the management of worms, that reduces diarrhea, which reduces fecal soiling, that's probably the single biggest risk factor for blowflies.
Yeah, 100%. And independent of each other as well, dags is really heritable as well. So just pulling out animals that have dags will help on that front as well. That's a good one. I've had success using garlic blocks. Is there any science behind this for keeping the blowflies at bay, or have I just been lucky?
I think you've probably just been lucky. Now, now it's a really interesting because we do a lot of work on essential oils. Essential oils do have significant impact on insects. They have insecticidal effects, and you could use various oils will deter flies, but you need to get the concentration quite high. Just giving them a garlic feed is unlikely to produce a high enough level of garlic at the skin surface to really significantly affect the risk. Would be my opinion.
From your work in other ectoparasites, is there essential oils that are showing promise as applications or as buckets or whatever?
No, I mean, the problem with essential oils is they are very volatile, so they evaporate very quickly. So we've controlled scab, for example, in sheep with essential oils. We'd use tea tree oil, but and you massage it in, and you take a stuck animal and you cover it in tea tree oil, and you massage the oil in, get it down to the skin, and it will kill all the mites off. But it evaporates in about 8 hours. But it's got no. If you have something like scab, where you kill all the mites and the animal, that's it. It's good. But if you have something like blowfly strike, where they're under constant threat from flies coming in to lay eggs, then you basically have to apply an essential oil every day to get persistent effect, and you probably have to massage it in. So I don't really see essential oils being useful for blowfly strike.
No, but it could be a treatment, but not a prevention, and that's really what it's all about.
Yeah, you possibly, but I mean, it's I wouldn't recommend it. I mean, if you have a lesion,
at the point of treatment, anyway, you're just going to put on.
Yeah, and it wouldn't be very nice if an animal sort of a wound and you're putting on a essential oil. I think it'd be quite sort of irritating for that wound. So I wouldn't recommend.
Yeah, no, great question. I guess similar question: are there any natural methods or products to prevent or treat blowfly strikes? That comes back to that side of things.
No, so we've more or less covered that there aren't. I mean, there are products that are marketed, but I don't think I personally wouldn't put any faith in them. The problem with blowfly strike is because animals can die so quickly. Once you get struck, the animal can die really quickly if you get multiple strikes. So on animal welfare grounds, apart from economic grounds, then you need to really be very, very sure. So it's not the sort of disease that you can really take chances with, would be my advice, because the consequences of losing animals is economically so high. I would tend to go for the test myself.
Yes, I think there might have been some people struggling to hear at the very start when you talked about the life cycle. So egg gets laid, maggot comes out. Was it 3 days?
Yeah. So the life cycle, the on-sheep life cycle is very, very quick, and that's the problem. So you can have a perfectly healthy animal that looks good on one day, and then it gets struck, and then a couple of days later, it's a heavy infestation, and that will quickly lead to its death.
Yeah, and like from research, have you got a number on like how many maggots is a heavy infestation?
Well, if there are 200 maggots per oviposition, I mean, probably thousands of maggots. It's more a question of surface area, but several ovipositions will give you 1,500 maggots. That would be quite heavy.
Yeah. How many eggs does one fly lay?
One fly lays 200 eggs at a go.
200 eggs.
And it'll do that every 2 or 3 days over the course of its life cycle.
will she just hang around the same sheep, or will she go to?
The behavior of individual flies, I don't know much about. They don't move very far. They don't move very far.
No.
We have done experiments looking at how far flies move, but they will hang around in the area. They might move away from the sheep and go and sit in the hedgerows. They've got to eat sugar, so they need plant material as well. So they have to sugars from plants to maintain their energy reserve.
Yeah. Are there any of the insecticide treatment options more or less persistent in the soil or more or less damaging environmentally?
I really don't want to get into the position of slagging off particular types of products. I personally am not a fan of pyrethroids. Pyrethroids can be quite environmentally toxic. All insecticides are environmentally toxic because they kill insects. So it's a question of which is the least damaging. I don't like pyrethroids. I think pyrethroids have got quite a bad environmental record, and so they wouldn't. I would tend to avoid pyrethroids personally. So that's my personal view. Particularly in watercourses and things, they're quite environmentally damaging.
On that side of things, well, on the subject of treatment options, are we seeing resistance now in populations? You do hear people saying that the drugs don't work as good as they used to, or they don't last as long as they're meant to on the bottle.
Yeah, there is. It's interesting. It's a very, very interesting question. There is no known resistance in blowflies in the UK.
Yeah, okay.
To any product.
Because there is abroad.
There is in Australia, for example.
Yeah.
Yeah. Why that's the case, we're not quite sure. And possibly one of the reasons is that a significant proportion of the blowfly population is coming out of carrion. So dead animals get infested really quickly by the same species of fly, but they're always adding. Essentially, they're a refuge population within carrion. So they're always adding to the blowfly population, and we don't get sufficiently strong selection. It also that's the one thing, carrion, but also I think we get what's sometimes called covert strikes. As I said, with small ovipositions, they can be on the animal for 2 or 3 days. If you don't get multiple oviposition, those maggots will drop off. The wound will self-heal, and no one's actually aware that they've been struck in the first place. But I think that might happen to some extent as well. Certainly, that's been recorded in Australia. So I just don't think the selection pressure is sufficiently great in the UK.
Right, that's very interesting, isn't it? But some of these products will work on other ectoparasites which are showing resistance. So we could inadvertently select for resistance in other populations by overusing one for fly strike control, could we?
Yeah, I mean, it's one of the reasons why we currently don't recommend using organophosphates for blowfly spray, because we don't want to have sheep exposed to more organophosphate than they need to be, so that we actually preserve the organophosphates. We know we've got resistance to macroscopic lactones in scab mites. So organophosphates are all we've got left for scab. So we really need to minimize the exposure of sheep to organophosphates if we can, and not use blowfly.
We've got another kind of a holistic question, I suppose. Can parasitic wasps be used for fly control?
No, is the answer. There's a fairly simple answer to that one. You'd need to breed up huge numbers of parasitic wasps, release them into the field, and they'd have to fly. I mean, it's not like you've got a contained population of flies in a house or a barn. They're just everywhere around the field, and so it would be really, really hard. There are parasitic wasps that attack blowfly larvae and pupae. As I know to my cost, because I've had my colony of blowflies in the lab infested by parasitic wasps, and it wipes the whole lot out. But to actually breed those wasps up in very large numbers and release them into the field in a way which would be effective against blowflies in the soil would be really, really hard to do.
Yeah. Are there other factors, and we've had a couple more questions sort of on that efficacy of treatment or not lasting as long? We've said there's no resistance, but is there other factors that might mean that people are not getting that level of treatment? I'm thinking about treatment method or
Yeah, I think
not
one of the
following the
key
packet
things
right.
that we get is rainfall. I mean, no matter what you've applied to the sheep, if it actually gets really wet and stands in rain for long periods of time, then nothing is going to be 100% effective. So if sheep are wet, because it's to do with how much of the product actually spread all over the animal, and in the sort of periods of really heavy rain that we've had over the last couple of years, where animals are just soaking wet, then nothing is going to work 100% effectively. You will get.
Okay. Is that washing the chemical way or just that they're really humid in terms of the flies being attracted?
Yeah, that I don't know. I don't know. I tend to think it's because the animals are just wet and the product hasn't covered it 100%,
Yeah.
rather than it washing off, because the binding properties I think are quite good on a lot of these products. But I couldn't swear to that.
Yeah. No, that's interesting. Um, Someone's asked which product or active ingredient then would you recommend pre-shearing? Because they've got that early issue.
Yeah, again, I'm not going to state a specific product. You just need to look at the period of residual activity. So if you want to protect them for say 4 to 6 weeks, then you just find the product that's got that 4 to 6 week protective residual activity.
Yep, I think it's always worth talking to your local vet.
Yeah.
And also, if you go on the NADIS website, there is a table of treatment options and it tells you the product, the chemical name, the treatment time period, how many weeks, and also withdrawal. That's
Yeah,
the
and the
NADIS.
SCOPS website is well worth looking at as
Scots will have
well.
it as well.
Yeah.
Yeah, worth a bit of a Google. Someone's asked how frequently should I ideally check my sheep?
At least daily. During the period of fly strike risk, then they should be inspected at least daily, because fly strike happens so quickly.
So fast,
Um,
yeah.
yeah, they really need to be checked at least daily.
Yeah. Um, is there any compounds or species of plant? I guess we talked about sort of essential oils earlier on, but is there any evidence to suggest that herbal leaves or herb leaves with different species in them might provide any form of source of off-putting chemical or help on this side of things? We know there's anthelmintic properties in some plaster species for
Yeah.
worms, but
I've not seen any evidence, any good evidence, that there are any plants that will have that effect on blowflies.
no.
These are very, very persistent flies, and blowfly maggots are pretty robust organisms, and they'll survive quite a lot. Once they start feeding, they really are quite tough. And no matter what you've given to the sheep, they'll find a site on the sheep, where they can lay their eggs, and the maggots can survive. They're quite good. They, they survive for millions of years, so they're
Yeah,
very well adapted to feeding on their host.
yeah. Why do we see more fly strike around wooded areas?
If we do see it
Mm,
more around, I mean, I know many people think that you get higher levels of risk around wooded areas.
yeah.
I'm not 100% convinced myself, but the flies are hanging around in the more highly humid parts of the field. If you take a field, and you look at the temperature and humidity in that field, the flies will be in the warmer, wetter parts of the field. Um, so if you've got woodland, the humidity is higher, so the flies may well be hanging around at the edge of that woodland where the humidity is high. But sheep blowflies like generally open, sunny conditions. They don't really go into shade. You tend not to get them
Mm,
inside woodland. They might
yeah.
be
Okay.
somewhere where the local humidity is higher, but they won't go into that woodland. They actually prefer going out in the bright, sunlit areas of the field.
Do manure heaps and slurry lagoons increase the fly population noticeably?
Not of sheep blowflies, no, they don't. So they don't breed at all in manure. They will feed on it, but they
Mm,
don't breed in it. You can't breed maggots in manure.
yeah. Sorry, the flies will feed on it.
They will, yes. The
Okay.
flies, the adult females need protein to mature
Yeah.
their eggs, and that protein usually comes from an animal source. But if you give them manure for long enough, they can eventually get enough protein from it to mature their eggs. But they won't lay eggs on it, and the larvae won't survive. Other flies
Mm,
will, of course, but blowflies, Lucilia, won't survive in manure.
Someone says, if you have high fly strike this year, will there be lots of maggots overwintering?
Yes, yes. So we do see some farms, for various reasons to do with the microclimate, have a higher fly population than others. And historically, those will be farmers that know they've got a high risk. And so we do see variation from farm to farm, and that's the geography and the local microclimate on that farm. And you will get a build-up of the fly population.
We've talked about prevention. What about if you've got strike? What is best treatment practice there?
I think most people will use a dilute form of one of the porons, one of the pyrethroid porons.
Yeah. And is the toxin from the maggots rather than the wound that kills the sheep?
Yeah, yes. It's they excrete ammonia, so their waste product is high, very alkaline, ammoniacal waste products, and so you get a change in the pH, alkalosis in the blood, which damages the heart and the kidneys. So it's to do with that waste product produced by the maggots.
Cool. I think we've actually run out of questions. We've had no lack of questions, and it's basically Bob on 8:30. So I think unless anyone's got any last questions to put in right now, I think we're probably good to wrap up. But
I'm sorry about the lack of hearing problem we had at the beginning.
Not at all. Not at all. Do you want to give your last slide, Richard?
No, it was only in case he was asking me about how you predict the beginning of the blowfly season. There is a formula, but it's quite complicated.
Aha.
I was just, in case anybody said, how do we know when the start of the blowfly season is? There is a formula, but you need to be, show me to do it?
Sure, yeah.
We got a couple of minutes. There is a formula, and it's, if anybody is sufficiently interested in doing it, you can actually work it out. So you buy yourself a max min thermometer. That's the first. But every day you have to record the maximum and the minimum temperature. You have to start doing that for January. You add up the maximum and minimum, divide it by 2, and that gives you the daily mean temperature. You then take the daily mean temperature and subtract 9. 9 is the threshold temperature for activity. And that tells you how much development you've got. Then you add up any positive values until you reach 150, and then you treat the sheep. And that's the beginning of the strike season. So if, just supposing it's spring, we've got 17 degrees in the day and 9 at night, so that's the average, that's the temperature. We add up the maximum and minimum, divide it by 2, that gives us 13. 13 minus 9 equals 4. And then we do that every day, and we add up the positive values. And when we reach 150, the flies are going to emerge, and that's the start of the blowfly season. So they're quite predictable in terms of how they respond to temperature. Yeah. And if you're minded to do that, if you want to go out and measure the temperature every single day, you can actually get the prediction of that beginning of the blowfly season quite accurate.
And there is a prediction forecast available. Is that right?
Yeah, so that's on the NADIS website.
On the NADIS.
For those people who subscribe.
Does that use that?
That does use that. And then, after that, then a much more complicated model for predicting the rest of the year. But getting that beginning of the season is really important. Once the animals are protected at the start, that's half the battle, really.
Great. No, thanks for sharing that last bit. I think we'll wrap up there. So a big thank you to Richard. It's been brilliant. And a big thanks to everyone else who's been on and contributed so many questions.
Thanks for having me.
Perfect. Right. Good night, everyone.